We've been referring to resolution along the way in previous slides, and now we're going to try to clear up misunderstandings or voids in your knowledge about it. These elements of resolution have a very dynamic relationship with one another. Note that here I'm talking about image resolution. I've already talked about screen resolution. I've been talking a lot about pixels up to now. We defined it earlier. To refresh, a pixel is the smallest unit defining a specific color in an image. You could think of them like atoms, and you could call them dots, but dots have a slightly different technical meaning. It's very important to understand that image pixels have no inherent physical size. That can be easily changed in the software, which you'll see in a moment. Display pixels are different, and they do have a fixed physical size, which will be explained in a moment. Since all images are rectangular, pixel dimensions are the dimensions of that rectangle. The pixel dimensions indicate the amount of information the image has. This information describes what the image looks like. The more information, the better. Pixel dimensions are expressed as the number of pixels wide by the number of pixels high. You can multiply them to get the total number of pixels in the image. For example, an image that is 1800 pixels wide multiplied by 1200 pixels high is 2,160,000 pixels, or 2.16 megapixels. That's essentially a measure of the amount of information contained in the image. Pixel dimensions are a better measure than total pixels, since dimensions indicate the aspect ratio of the image. Next, you need to understand the concept of pixel density, which most software, including Photoshop, calls resolution. I prefer to use the term pixel density. I reserve resolution as the overarching term that includes all of the elements listed here and on the next slide. Pixel density is measured in pixels per inch for digital displays and dots per inch, or DPI, for printed output. Pixel density indicates how much physical space on the screen each pixel takes up. Higher pixel density obviously means that more pixels are packed into each inch, meaning that they're smaller. That results in sharper images with finer detail. The term physical size is just what it sounds like. It's also known as document size. It indicates the physical size of the image when printed or displayed on a screen. The width is calculated by dividing the horizontal pixel dimensions by the pixel density. The height is calculated by dividing the vertical pixel dimensions by the pixel density. You can see both of these calculations in the image here. The image is 1200 by 900, and the pixel density is 300 pixels per inch. That gives you a 4-inch by 3-inch physical size. There are two ways used to measure physical size. Use points for precision measurement in designs done in desktop publishing software. Points are used for typography and layout design, partly because fonts are measured in points. But convert to inches for measurement in final print outputs, so you know exactly how big or small something's going to be when printed.